everyone, it's Alyssa and welcome to You Can Learn Math. Today is on 30, 60, 90 triangles. No, I am not talking about counting triangles and throwing, 180 triangles at your face. No, I'm not. I am talking about this. Yes, I drew that ahead of time. I did not count. I didn't count on myself being able to draw that easily in real time because, as viewers of this channel know, I'm not great at drawing triangles on screens. Just not. It's not my forte. I know my weaknesses. So this is what we talk about when we mean a 30, 60, 90 triangle. It's one with a 90-degree angle right there in the corner. This small one up here is 30 degrees, and this one down here is 60 degrees. Why is this special? Why should we care? It's special in that it has a easily recognizable, to a mathematician, pattern to it. And this pattern goes over and over again, so it's good to know this pattern. It's a shortcut. And 30, 60, 90 triangles seem to pop up a lot in the world. So here is the pattern you're going to see in your book. It's going to have down here by the 60 degree, it's going to have X. On the hypotenuse, the long side opposite the 90-degree angle, it's going to say 2x. And the side along the leg alongside the 30-degree angle is going to be x times the square root of 3. Most of your problems that you get with this, they're going to start one way and then they're going to take a swerve down a more difficult path. So we're going to start where your math book is likely to start and then swerve down that extra garden path. That's going to be a little more tricky. Your introduction is going to look something like this. They're going to give you, and I should really just paste it again because again, oh, come on. I want it up here. Come on, whiteboard. That's good enough. There we go. They're going to give you something like this. They're going to say, this is a right angle, and they're probably only going to tell you one of these. They're either going to say this is 30, or they're going to say the other is 60, but not both, because they're going to want you to recognize, oh, a 30, 60, 90 triangle. Because if you have a 30 and a 90, the only thing that can be is 60. And likewise, if you're given that this is 60, the only thing that can be is 30. And they'll tell you one side of it, like say this side is 10. And then they'll go, okay, what is this side? SAT questions, this shows up on SAT questions all the time. If you are not familiar with the 30, 60, 90 triangle, you wouldn't be able to do this without a calculator at your side. And they will throw these kind of questions at you in the non-calculator portion. So definitely memorize this pattern. It's very important for those kind of tests. So in this scenario, this side here is 10. What are my other sides? Well, if we look at our original pattern, the hypotenuse is equivalent to 2x. And my hypotenuse here is 10. So if I write it like that, it becomes a pretty straightforward algebra problem saying 2 times x equals 10. So I divide both sides by 2, and I know that x is 5. Well, if I look at my original pattern, it says that the leg that's next to the 60-degree angle is just x. So now I know down here, this leg next to the 60-degree angle is my x, or 5. And I want to know this final side. My pattern over here says that is x times the square root of 3. Again, my x is 5, so I know this side is 5 times the square root of 3. And that's really all there is to it. And this is for those beginning problems that they're going to show you. And they can give you any one of these three sides. They may say, okay, over here, this is 7 times the square root of 3. What are the other sides? Same thing. Okay, well, I know the side by the 30 degrees is x times the square root of 3. So if this side is 7 times the square root of 3, x must be 7. And then I can fill in the blanks. This bottom one by the 60 degree would be 7. This is 2 times 7, or 14. So far, so easy, right? The hardest part at this point is memorizing this pattern. Here's my way when I was learning this, way back in the day, ages ago, ages. Here's how I remembered it is, all right, X, that's the smallest because both of these I'm multiplying X by something that's going to make it bigger. So I know in my head the shortest side is X. Okay. So I'm starting there. The shortest side is X. This is the shortest side. Then I know, oh, there's a 2X and there's an X times the square root of 3. Which one's which? The leg that's next to the 30 is square root of 3. It's only touching the 30, that leg. This one is the hypotenuse, but it touches the 30 and the 60. No. When we're talking about what touches those small sides, it's the one that only touches the 30, there's a 3, is the one with the square root of 3. That may not work for you, but that was my sort of methodology where I was able to keep them straight. Okay, now I mentioned that they're going to kind of take a swerve towards more difficult problems very quickly. It's inevitable. Same thing happens with the 45, 45, 90 triangles. If you are interested in a video on that or you have questions on that type of triangle, I do have a link in the description below. All right, so here's the next thing that's likely to come along. And again, they might give you either one of these angles. It doesn't matter which, just as long as they're telling you in some way it's a 30, 60, 90 triangle. And here's what happens. They'll start putting, like say over here on the side that I know is 30, they'll put 5. Okay, what are all the sides? Wait a minute, 5, but this is the side alongside 30 degrees, the leg alongside 30. So that's the side that is X times the square root of 3. If that's 5, what is X? It's going to be messy, but we got to do it. We need to solve for X. So how do we do that? This is X times the square root of 3. To undo multiplication, we need to divide. So we're going to divide both sides by the square root of 3. So we get X equals 5 over the square root of 3. But we can't leave a square root in the denominator. Math law forbids it, and we always obey math law. So we can't have a square root in the denominator. We need to get rid of it. Here's how you get rid of this. I'm just going to write this over to the side separately. Whatever square root is in the denominator, you're going to multiply the whole thing by that square root over itself, because the square root over itself is equal to 1. Like 5 divided by 5 is 1. Pi divided by pi is 1. Square root of 3 divided by square root of 3 is 1. If you multiply a fraction by 1, you're not changing it. You're not intrinsically changing what it is. And what happens when we do this? On the bottom, square root of 3, back out a little bit, there we go. Square root of 3 times square root of 3 on the bottom is just 3. That makes the square roots cancel out. And on top is 5 times the square root of 3. We can't do anything different there. So X is equal to 5 times the square root of 3 over 3. Again, these are the same. They are identical. We've just made it look a little different in that the square root is out of the bottom, but they are the same. Just like if I said, like 1/2 and 3/6, those are the same thing. They're representing the same amount. They just look a little different. All right, so now I know my X is 5 times the square root of 3 all over 3. That's my X. Now what's my hypotenuse? The pattern says it's 2 times X. So 2 times 5 times the square root of 3 over 3. Just like other fractions, like if I was going to multiply 2/5 times 3, the way I would do that is put 3 over 1, then multiply the top numbers and multiply the bottom. Same exact thing. Even though it's got that square root, that radical in there, same thing. So I'm going to put it over 1. So on top I have 2 times 5 times square root of 3. 2 times 5 is 10, and the square root of 3 just hangs on. Kind of like an x, like if I was doing 2 times 5x. I can multiply 2 times 5 and get 10, and the x just hangs on. Square root of 3 is like that. And on the bottom, I have 1 times 3, which is 3. So my hypotenuse is 10 times the square root of 3 over 3. One thing I do want to mention is this one little last sort of thing to look out for. If you had a problem very similar to the one that we just did, but instead of it being 5, let's say if this side were 6, craziness, right? One whole more, but it changes a lot. Here's why. You remember the pattern we just had, we ended up with 5. We had 5 square root of 3 over 3 and 10 square root of 3 over 3 on my 3 sides. I told you I couldn't draw triangles. Yeah, it's awful. Okay. So let's follow this pattern over here. It's going to be the same kind of thing. After we do all of our little math, we did, dividing by square root of 3, we would end up with 6 on the left, as we started with, 6 square root of 3 over 3, and 12, 6 times 2, square root of 3 over 3. But here's what you need to look out for. These you can simplify. You can't leave it like this. If you don't simplify it, it's going to be marked wrong. So simplifying fractions. So over here on the bottom, I have 6 on the top, 3 on the bottom. 3 goes into 3 one time. 3 goes into 6 2 times. So to simplify this, it becomes 2 times the square root of 3. Over here on the hypotenuse side, 12 and 3. That I can simplify. 3 goes into 3 one time. 3 goes into 12 4 times. 4 times the square root of 3. And, if you're doing this and you get to this point where you find this side and you find it 6 square root of 3 over 3, you can go ahead and simplify it right then and then multiply by 2 to get the other side. As you can see, that would give you the same answer. It doesn't matter when you simplify in the process, just before you finish the problem, make sure that you've checked to see if you have a fraction, if that fraction can be simplified in some way. And that's it. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.